Hi friends, welcome to this chemistry session. Today we are going to learn about Sn1 mechanism, which is the part of haloalkanes. So Sn1 mechanism is basically unimolecular nucleophilic substitution reaction. Now let me tell you what is meant by unimolecular nucleophilic substitution reaction. Unimolecular means one molecular, uni means one, molecular as usual molecule, nucleophilic. So nucleo means deals with the nucleus, it means positive charge, means it mainly nucleophilic deals with the positive charge species. So philic means loving. So those species which are electron rich and which are looking for the nucleus or positive charge, such species can be termed as nucleophilic. Electron rich species are also called as nucleophilic species. So substitution, putting one substance or thing in place of other. So this is the substitution and reaction. The process of getting a product from the reactant is nothing but the reaction. The term of Sn1 represents in this way. So S means substitution, N means nucleophilic, 1 means unimolecular. So unimolecular nucleophilic substitution reaction can be represented as Sn1 reaction. The main thing that we need to notice here is the rate of reaction, that is Sn1 reaction, is directly proportional to the concentration of alkyl halide. So the rate of we know that rate of reaction depends upon the concentration of the reactants. Hence, here the alkyl halide is taken as the reactant of this Sn1 reaction. So this rate of reaction only depends on the concentration of this alkyl halide, and Sn1 is favored by the tertiary alkyl halides. So this carbon which we are talking about, if this carbon atom is attached to 3 other carbon atoms, then we call it as tertiary carbon, and this is primary, because this carbon is attached to only single carbon and it is attached to 3 hydrogen, so it is primary. So I hope you know the difference between primary and secondary, all these things. So if it is in this way and so on, so this carbon is attached to 2 carbon atoms, right? It is secondary. If it is attached to 3 carbon atoms, it's tertiary. If it is attached to single carbon atom, then it is primary. Friends, we have seen about the introduction of this Sn1. So let us look into the mechanism. So first, this mechanism is divided into 2 stages, like steps. Let me first write the general mechanism, general reaction of this Sn1. So it is this way. It is tert butyl bromide. Then it is going to react with aqueous NaOH. It is going to give us tertiary butyl alcohol, right? So the first step number 1, goes in this way: ionization of butyl bromide. This is the first step. So we are going to take tertiary butyl bromide. Then it is going to undergo ionization. Remember, this is a slow step. We always know that the slow step is the rate determining step of the reaction. So you can also write as RDS, rate determining step. When I am going to ionize it, so it is going to leave out carbocation plus Br minus. This is going to be the products I am going to get from ionization of tertiary butyl bromide. Right now, I will make use of this carbocation. This is the carbocation, and we know that the carbocation will be sp2 hybridized. If it is sp2 hybridized, then this particular carbocation is going to be planar, meaning all these methyl groups will be present on the single plane. So for example, if I consider it as a plane, then if it is the carbon, the main carbocation, and methyl groups are distributed on this plane, so it will be in a single plane. It means the methyl group will not protrude out or below this plane, it will be on a single plane. This is what I want to tell you. This is the carbocation, right? Now this carbocation we need to make it use in the next step. So in the previous step we got carbocation this way. Now whenever I am going to react it with aqueous NaOH, so it is going to be the first step. So NaOH is going to give us the H minus. This is the nucleophile I was talking about. We know that this carbocation, this is sp2 hybridized, planar, meaning this carbocation will be present on the single plane. So the OH, that is the nucleophile, can attack either below or above. So it can attack from either sides. So we get two types of configurations. One is retention and the other one is inverted. So let us see how we can get it. So this is the first configuration. The other one is in this. This is the retention. The other one is inversion. So this is the fast step. So this, whatever the product I get, it is nothing but third butyl alcohol. So to understand this retention inversion configuration, let me get simple analogy. Imagine this as an umbrella. I'm not good at drawing, but still I can get things clear for you. So imagine you're holding an umbrella. There is a heavy wind blowing towards you, right? But still, if your umbrella is strong, then what will happen? It can retain, means it can withstand the speed of this wind, and it will be in the same posture forever, or till the wind goes, it will remain in the same state. It will not change its position, or it will not change its shape. Imagine if I take another umbrella, if it is very weak, बेचारा खाया पिया नहीं होगा, भूखा होगा. So what will happen if there is heavy wind? It is going to change shape. So if it is not strong, it is going to form like this. So this umbrella, it is going to retain. It is going to invert its position. So we call it as, we can rename it as retention, and I can call it as inversion. This is how we can understand the retention and inversion configurations. So we will meet in the next video. Thank you.